Hi there, my name is Yassine and I have a question for you. If I were to drop these two objects, one being a pencil that was about 10 grams and one being a noticeably heavier brick, which would hit the ground first? It is a seemingly simple question, but a lot of you might be inclined to think that the heavier brick would hit the ground first. But as it happens, and if you remember some physics, they actually hit the ground at the same time. So why is this the case? Well, this can be explained by a simple piece of 17th century mathematics, Isaac Newton's second law of motion, which is one of the most important laws you'll learn in the world of introductory physics. But before that, you should know what acceleration means. In physics, acceleration is the name we give to any process where the velocity changes. And since the velocity is a speed and a direction, there are only three ways for it to accelerate: change the speed, change the direction, or change both. So we know objects can only accelerate if there are forces on them, and Newton's second law tells us exactly how much an object will accelerate for a given net force, which can be expressed by this formula: F equals ma. This formula can be rearranged to make the acceleration the subject of the formula. If we do so, we'll see that a is equal to F divided by m, where a is the acceleration of the object, F is the net force on the object, and m is the mass of the object. Looking at this formula, we can see that as the force increases, so does the object's acceleration, and vice versa. Also, as the object's mass increases, the acceleration decreases, and vice versa. For instance, if I drop this wooden block from this height, the ball goes only 0.63 meters. But when I drop a heavier rock from the same height, the ball goes 1.21 meters. The rock uses a much larger force to apply more acceleration to the ball and send it flying farther. The other part of Newton's second law, as the object's mass increases, the acceleration decreases, can be demonstrated in the same way. Using the same catapult, I can send a heavier stone flying a much shorter distance than a tiny ball. The stone has a greater mass, so the acceleration is smaller. Alright, in our original case, the two objects are in free fall. In fact, the only force that is acting on them that isn't negligible is gravity. And here on Earth, the acceleration due to gravity is approximately equal to 9.21 meters per second squared. This is a constant, and since F divided by m is equal to a constant, the force acting on an object is always directly proportional to its mass, which means that, for example, if the mass were doubled, the net force would be twice as large. So we can increase or decrease the mass of an object however much we want. The acceleration due to gravity will always stay the same, which means that objects will fall at the same rate. I'm Yassine BENTAYFOR, and that was a video about Newton's second law of motion. Thank you for watching.